Hi everyone. In today's lesson, we're going to talk more about implicit differentiation. So here I've took the liberty of writing down some general guidelines for implicit differentiation. You can take a look at them later on if you're having some trouble. I'm just going to talk through them. So example number 1 says find dy over dx using implicit differentiation. So we're going to take the derivative of each of the pieces. So the derivative of x negative x squared is negative 2x. And the derivative of this piece, well, this is a very unique situation here. So this xy squared is actually a product rule. We're multiplying the product of x times y squared. So another complicated scenario now is because we have this minus sign. So it's going to mess things up. So what we can do is make it a plus and a negative x, and then it'll make it much easier. So with our product rule, we're doing negative x times y squared. So I'm going to call this my high and this my low. So remember the product rule is low times d high plus high times d low. So the low function is your y squared, and your d high means your derivative of your high. So the derivative of negative x is simply negative 1. So we're multiplying those together, plus my high function, which is negative x, times my derivative of my low. So my low function is y squared, and the derivative of that is 2y. But you have to remember, since I took the derivative of a y term, I need a dy over dx. So if I want to clean this up a little and simplify it, it's negative y squared minus 2xy times dy over dx. So that is what I'm going to put right in here for this piece. So minus y squared minus 2xy times dy over dx. Now the next piece, the derivative of positive 5y is positive 5. But since I took the derivative of a y term, I have to multiply this by dy over dx. And now the next term is the derivative of this constant, which is 0. And last but not least is my derivative of negative 2x, which is negative 2. So the goal is to collect all dy over dx terms to one side, and all the other terms need to go to the other. So this is where it could get a little confusing. So you might want to try to do this without showing every single step, because then it might just get too much on the paper. So I'm going to keep this term and this term on the left side. So I'm going to keep the negative 2xy times dy over dx plus my 5 times dy over dx. And all the other terms, so this one and this one, get to be moved to the other side. So if I want to take this negative 2x and bring it to the other side, I need to add it. So there's already a negative 2 here from this one. So I need to add to it 2x. And if I want to bring over this negative y squared to the other side, I have to add it. So plus y squared. And now I'm at the same step that I was yesterday. I have 2 dy over dx's. So I'm going to take out a GCF of dy over dx. So when I take this term and divide it by dy over dx, I'm left with the negative 2xy. And when I take this term and divide it by the dy over dx, I have positive 5. And that's equal to negative 2 plus 2x plus y squared. And dividing both sides now to isolate this dy over dx, which is attached to this by multiplication, we can simply divide it. So dy over dx is negative 2 plus 2x plus y squared all over negative 2xy plus 5. So that is my implicit differentiation. That's part A. So part B says find the dy over dx at the point 2, 3. So part B, if the point is 2, 3, I'm going to substitute x to be 2 and y to be 3. So my dy over dx is negative 2 plus 2 times x, which is 2, plus my y, which is 3, squared, all over negative 2 times 2 times 3 plus 5. So take a minute and pause the video, simplify this, and hit resume when you're ready for the answer. All right, this is what I got. So my slope of my tangent line at x equals 2, this is my x value, right? The slope at x equals 2 is negative 11 over 7. All right, let's try another example. So same concept, find dy over dx using implicit differentiation. So we know if I want to take the derivatives of sine and cosines, we need sine, cos, negative sine, negative cos. So I want to take the derivative of sine. So I'm going to look at sine and look to the right. So the derivative of sine is cosine of y, but I'm taking a derivative with respect to y, so I need to multiply by dy over dx. Now this is a product rule. I have x squared times y to the third. So I'll call this my high and this my low. So we've got low first, low, times d high, which is 2x, plus high, x squared. D low, derivative of low, is 3y squared, but I took the derivative with respect to y, so I need a dy over dx. So if you want to clean it up, it's 2y to the third x plus 3x squared y squared times dy over dx. The order of the x's and y's doesn't matter here because, multiplication is commutative. So we can keep going and write that in. So I'll use a different color for the product rule. So plus 2y to the third x plus 3x squared y squared times dy over dx. And next, I want to take the derivative of negative cos. So if I'm here at negative cos, I can't go right anymore, so I have to go back to the beginning. So the derivative of negative cos is positive sine. And then last but not least, I have the derivative of 2y. So the derivative of 2y is simply 2. But since I took the derivative of y, I need to multiply it by dy over dx. So the goal now is to get all terms that have dy over dx with them to one side. So this we're going to keep on the left side. We're going to keep this on the left side. And we need to bring this term to the left side while simultaneously bringing these two terms to the right side. So let's write down what we have. We have cosine y times dy over dx, and we have plus 3x squared y squared times dy over dx. And this we're going to bring over here, so we have to subtract it. So minus 2 times dy over dx equals, we're going to move this to this side by subtracting it. So minus 2y to the third x. And we're going to take this term, bring it to the other side by subtracting it. So minus sine of x. So now all of my dy over dx's are on the same side. So I can take out that GCF of dy over dx. And if I divide this term by dy over dx, I'm left with cosine of y. If I have this term divided by dy over dx, I have 3x squared y. And last but not least, if I have this term divided by dy over dx, I have minus 2. And everything else will stay the same. So Last but not least, since this dy is attached to those parentheses by multiplication, we're going to simply divide to get dy over dx by itself. So negative 2y to the third x minus sine of x all over cosine of y plus 3x squared y minus 2. So that is your answer to the first part. Now the second part is asking us to find dy over dx at the point 0 pi. You may need to round your answers to the nearest tenth. If you're going to use the calculator, you must be in radian mode. So take a minute, try to see if you can plug in your x value of 0 and your y value of pi into the equation that you found in part A, and hit resume when you're ready for the answer. All right, this is what I got. So let's take a look. All I did was I plugged in y to be pi everywhere I saw a y, and I put a 0 everywhere I saw an x. And after simplifying it, I got that the numerator came out to 0, and the denominator came out to -3, and 0 divided by anything is 0. So this tells us that the slope of the tangent line at x equals 0 is in fact 0. If you had trouble with getting this number, remind me in class. I have no problem going over it. But that's it for today. If you have any questions, please jot them down. Otherwise, we'll see you in class tomorrow. All right, have a good night.